Okay, let's give me some heterogeneous mixtures. What's a heterogeneous mixture? Give me an example of one. Tapioca pudding. All right, I'm done with that. How do you spell tapioca? P-I-O-C-A? Sure. Not true. So not true. What is interesting about the tapioca pudding that no other pudding can claim?
Little boogers in it.
Anybody? It should be the pudding. If you're going to give a kid pudding, it should be the pudding you give the kid. What's tapioca?
It's a rice, isn't it? Is it water? Gelatin-y water?
It's a piece of protein.
Yeah.
It's the only pudding that's got like, what is it? Something crazy, like 40% protein.
Really?
Yeah. So if you're stuck on a desert island and somebody says you get one kind of pudding, here's 3 pallets of it, take tapioca. Yeah. Next, give me another one.
Italian.
What?
Italian salad dressing.
Yeah, that one's great. Anybody have any that they're not sure what they wrote down?
What about milk?
I would say no on that. If you wrote maybe raw milk, maybe, but if you just said milk for everybody in this room, I would say we're assuming that you mean the milk that you can buy in the grocery store. And what does it say on the label? It says pasteurized, but I don't care about that. It says homogenated or homogeneous. So that's definitely the next one, right? So you could write homogeneous milk for the second one, and you could write raw milk for the first one. So example for, yeah.
I have a question. So is this anything in nature that?
It doesn't have to be in nature, it could be anything at all. I mean, Italian salad dressing isn't like a nature thing.
So we were talking about food, so I was just wondering about. what
No,
about
you could pick
anything else?
any, I mean, food, sure. How about a piece of paper? How about this piece of paper? Is this a homogeneous mixture? Is this a mixture or is this a pure substance? It's definitely a mixture, right? What kind of mixture is it?
I don't know.
It's definitely hetero. How do you know it's hetero?
Because there's ink and.
Some of it's black and some of it's white, and if you zoom in really carefully, you can see the fibers of the paper. There's also a staple here. So this is definitely a heterogeneous mixture. Okay, so it doesn't have to be something out of nature. It could be anything.
So, getting technical, like the blood cells that they talk about in the book, seeing them with an unaided eye. I didn't use that for an example, but if we were to put that,
I'm not going to ask you anything tricky. Blood would be a tricky one. If I'm just looking at the blood looks what? Homogeneous. But if I grab a microscope, it's absolutely not homogeneous, which I think is a stupid way to talk about this homogeneous, non-homogeneous mixture, because if you have a powerful enough microscope, nothing looks homogeneous. No mixtures look homogeneous, right? So I would say naked eye is your tool. All right, so I'll put down blood and milk. Anybody have any that they're not sure about that they wrote down? They want to ask?
for homogeneous
Sure.
blood, how about black coffee?
Black coffee? Yeah, that'd be okay.
Jello.
Jello? Sure.
The book used blood as heterogeneous.
Yeah, we just talked about
I
that.
know, just so you know. the book
I
actually
totally
wrote
know,
that.
but
Oh, okay.
how much?
I put it in for the first. myself.
If you can explain why, that's fine.
Okay.
Plasma is homogeneous.
If you just centrifuged out plasma, it
Yes.
would look homogeneous for sure. Physical and chemical change? What's the difference there?
Composition change.
Okay.
Physical is a formula.
Composition change or a formula change? And by formula change, we mean like H2O turning into H2s and O2s, something like that. That's an actual chemical. I have a different molecule or atom than I had before. And what were those observations that were going to indicate to you that you just witnessed a chemical change versus
Like rubbing alcohol.
okay, so they were what? Color change? So something, I'm looking at something and all of a sudden it changes colors.
Presence of bubbles or gas.
Gas.
And precipitate.
And a PPT created. So if I'm doing something and the color of that thing changes, easiest example would be a marshmallow in a campfire. That marshmallow has been chemically altered. Bubbles or gas evolves. You dribble vinegar on baking soda, you get bubbles. That's carbon dioxide was just created, so that's definitely a chemical reaction. And the PPT, the precipitate, so you put two solutions together that you can see through, they're clear, and then when they run into each other, all of a sudden you can't see through them anymore. Yeah.
How come heat isn't on that?
What?
That's just one of the observations for chemical change.
Because heat, if I take boiling water and I take water and and the water freezes, one of the products is what? And the other product is? No. Heat. Was that a chemical change?
No.
It was just a molecule that lost some energy.
Okay.
And that always happens, right? What are the coldest days on the mountain if you're skiing or something? Are those the days when it's snowing? The snowing days are not the cold days because when the water turns into ice, it releases heat, so it actually starts to heat up. Same thing when it rains. As soon as it starts to rain, heat is released and the entire environment warms up. Doesn't mean you're going to be warm because now you're probably wet, but define the term unit. What do you got there?
Standard of measurement.
I have a standard, and I'm going to measure something. You got to have that standard part in there. Why was it developed?
To replace an inconsistent one.
Inconsistent? I wouldn't say inconsistent. Go back to our definition. Yeah, let's go back to our units definition, and we're going to standardize it. So the English system or the empirical system was standardized usually within a country and sometimes not even within the country itself. So this allowed for international standardization was the real reason. You could say ease of use, but that's not really the reason. They just made it easy. Since they were going to make everybody standard, they might as well make the thing that they're standardizing everybody to something easy to use. And when they did it, it's based off of what? 10. So let's just make it based off of units of 10, so that'll make it easy for everybody. Okay, so decimal format for this first one, 235,800, right? Yeah. Do I put a decimal place anywhere? What do you think? Negative. When I'm looking at the scientific notation, how many significant figures are here? 4. So if I put a decimal place after that 0, what would that tell me? That would tell me there's 6, and there aren't 6. There's only 4. Convert that to scientific notation. So 6.5895 times 10 to the 4th. Okay. Decimal format.
Could we have chosen to put our decimal anywhere?
Absolutely not.
It always has to be.
The rule for scientific notation is one number, actual number, a non-zero number, a decimal place, and then everything else that you need to put down. if you were gonna use a different standard, so this is scientific notation, engineering standard, for some unknown reason, they're not the same. In engineering standard, it's 2 numbers, then the decimal place. But for scientific notation, it's 1. So 0.000, no, that's not. 0.005894, and then let's throw that 0 in front of the decimal place. We had that discussion as to why, correct?
Yeah.
Okay. And then scientific notation of this last one. 9.23 times 10 to the -4th. Okay. All right, so we're going to convert some inches into meters. And so I've got 285 inches. And for every 1 inch, there are 2.54 centimeters. And for every 100 centimeters, there's 1 meter. And so when I've got it like that, I can cancel the inches out with the inches, and then the centimeters out with the centimeters. And somebody got an answer for me? 7.2, what?
7.24 meters.
7.24. Are we okay with that? Are we okay with it being 3 significant figures? The given information was in 3 significant figures, so the answer is going to be in 3 significant figures. Yeah?
It's kind of hard to see because there's a glare in the windows. That one.
Which one?
Which one?
I don't know.
Want me to just put this down?
Sure.
And that is, we have to fix that one.
How's that?
So
Good deal.
it might be this projector right here. Is it on? It looks like it's shooting.
I think it all depends on where
That
you sit.
projector is what's
Oh.
putting the, I can't turn the
Oh,
projector off.
well, that's true.
You are absolutely correct,
It might be a
but.
blonde thing for me.
All right, so we're going to go feet per second. We're going to turn this into miles per hour. So I've got 24.5 feet per second. And then I need to go hours and miles. So I'll do the seconds first. I'm going to put 60 seconds here and 1 minute. And then I'm going to put 60 minutes here. I'm going to put 1 hour here. And then then I'm going to put 5,280 feet here. I'm going to put 1 mile there. And so then my feet are going to cancel out with feet right there. And my hour will not cancel. I don't want it to. My minute, come on, really? You suck. My minute will cancel out with my minute, and my seconds will cancel out with my seconds. And then what units do I have left? I just have miles, and I have hours. Oh, that feet thing didn't get canceled out. Okay, and so they're the units that I'm looking for, miles per hour. And so I'll put down miles, and I'll put down hours. And do we have a number for that? Anybody?
16.7
That sounds right. 16.7 miles per hour. And that's the correct number of sig figs. We're given 3, so I'm going to report 3. All right, and then this last question. I'm looking for milligrams, right? What's another way that they could write this to make this question a little bit more difficult? Sure, they could say grams, or they could not use this word here, milligrams. What word could they put in there for the milligrams?
cc.
No, not the same thing. No, not the same thing. No, this is, what unit does milligrams measure? What parameter?
Wave.
No, but you're on the right track. mass. It measures out mass, right? So this word here, milligram, could be swapped out for mass. And then you would have to realize that I've got like milligrams and a milliliters and a milliliters, and I need milligrams for this problem because they were looking for a mass. We had a question earlier last week when we were doing one of these, and it said, what's the volume? And so you had to realize that the volume that they were looking for had a unit of milliliters. Okay, so this time they ask us for milligrams. So when I set this up, I'm going to write 20 milligrams and then 1 milliliter here. Why did I put the milligrams in the numerator?
Because that's what you want in.
That's what I want. I don't want it in the numerator, so that's where I put it. Whatever I want, I get to set the railroad track thing up however I want it to end. And so I set it up correctly with milligrams in the numerator. So that milligram came with a milliliter, so I need to cancel that out. It was given in the problem. So then I can write my 2.6 milliliters here, and then I can cancel out my milliliter number. And then I've got only milligrams as my answer. And what is it, like 34.6?
Repeating.
6 repeating.
Okay. All right, so this is the hard part of this question. How many sig figs are there?
1.
There's 1. The 20 doesn't have a decimal place after the 0. So it's 30. But it's written like this with no decimal place after it.
So when you're giving
Right.
medication, are you gonna give 30 milligrams or are you gonna give like 34 milligrams?
This was a question just to make sure that you guys understood significant figures. How do you think this question should have been worded? They should have put a decimal place right there, right? Does that make sense? I mean, if you read this question, this solution strength is 20 milligrams per 1.5 milliliter. Somebody made that. Who made it? Who do you think made it? Some pharmacist or some pharmaceutical company. Do you think they didn't measure something that had units of milligrams to the actual milligram number? No, probably not. So there should be a decimal place if you're going to be doing this for real, but I just wanted to see if you catch that it should be 30.
Why can't you go by the 2.6, because that's what your syringe is? Why can't you say there's 2 significant?
There are 2 significant figures there, and there are 2 significant figures in the 1.5, but there's only 1 in the 20, and you have to use the worst.
Because so you have to still go over all 3, not the solution that you're talking about.
This is the solution I'm talking about.
Well, it's saying, okay.
I am taking 2.6 milliliters of this solution. I only want 2.6 amount of this guy here, so this solution's strength, well, it's telling me exactly how much. Since all 3 of these numbers are used in the calculation,
Okay.
I can only use the worst significant figures for my answer.
If you measure with a thimble and I measure with a bucket, we have to go with a bucket.
True statement. I don't think I want a bucket of chemical or drug or a syringe the size of a bucket. That sounds terrible.